Hello, Ms. Smart here with help on today's lesson 17 assignment. So we're focusing again on equations and inverses, only we've been using some function notation today, which doesn't really show up a whole bunch in the assignment because the big idea is finding inverses. All right, so let's get started here on number 2. The distance d in kilometers that a car travels at a speed of 80 kilometers per hour for t hours is given by this equation, d equals 80t. If the car has gone 120 kilometers, how long has it been traveling? So in this example, this 120 kilometers represents the distance, so d. So I'm going to solve for part A, 120 equals 80t, and I do this by dividing by the 80. Okay, 120 divided by 80, grab my calculator. Let's see here, there it is. 120 divided by 80 is equal to 1.5. So if t equals 1.5, then the car has been traveling for 1.5 hours, or you could say 1 hour and 30 minutes. Rewrite the equation to represent time t as a function of distance d. So if our original equation was d equals 80t, then if we want to rewrite this so that t is the output and d is the input, we can just divide by the 80. And now we have t by itself. So the inverse, t equals d divided by 80. All right, on number 3, we're matching a function and its inverse. So all of these functions and inverses have the same variables, x and y, and they all use the number 2 and the number 3. So we have to think about when we change the input and output, we also change not just the operations going on like add, subtract, multiply, divide, but also the order in which those operations are done. So for A here, it says y equals 2x minus 3. So I know I'm going to multiply by 2, then subtract 3. So the opposite of that, so I need to find a function where it tells me to first add the 3 and then divide by the 2. So add the 3 first and then divide by the 2. Looks like this one here. So the input and output is reversed, and then I'm going to add the 3 first and then divide by the 2. Add the 3, divide by 2. So A matches with equation 2. B, this one's really simple. I'm just looking for x equals y over 3, or y divided by 3, and that looks like equation 5 is the inverse. So this one is equation 2, B is equation 5. All right, on C, this tells me to multiply by 3 and then subtract 2. So I'm going to look for an inverse that has me add the 2 and then divide by the 3. So when I look at these, equation 1 with the y plus 2 on the top, that comes first, and then divide by 3. So equation 1 matches with C as its inverse. These one-step equations, like all we have to do is just kind of solve it. And I know I'm looking for x equals y plus 2. That's equation number 4. Whereas on E, I would solve for x by subtracting the 2. So I'm looking for x equals y minus 2. That's equation 6. And then on equation F, this tells me to subtract the 2 and then divide by 3. So I'm going to look for an equation that first multiplies by 3 and then adds 2, following the order of operations. And so that happens here on equation number 3. So there we go. There are the matchups for a function and its inverse. Okay, number 4, functions h and j are inverses. If each point is, functions h and j are inverses. When x is negative 10, the value of h of x is 7. And then here it's just written using function notation. So what that means is h of negative 10 equals 7. So when x is negative 10, h of x is 7. Okay, when x is negative 10, h of x is 7. So then what is the value of j of 7? Well, if h and j are inverses, then what happens is that at every single ordered pair for that original function, the inverse has the opposite input and output. So in function h, when negative 10 is the input, 7 is the output. So in function j, if 7 is the input, then negative 10 is the output. All right? So in a function is inverse the input and the output reverse at every single point. So then for B, determine if each point is on the graph of H, on the graph of J, or neither. So the negative 7, 10, well, if H of negative 10 equals 7, that's this point. Because the first number here, that's the input, so x, that's the output, so y. So this is on function h. And then the reverse of that is the same as right here. The input is 7, so x. The output is negative 10, so y. So this is on function j. Okay, and then we have number 5, the cricket problem. So it says, get this back up to the top, there we go. Crickets make chirping sounds by rubbing their wings together. The number of chirps they make is closely related to the temperature of their environment. When the temperature is between 55 and 100 degrees Fahrenheit, we can tell the temperature by counting the number of chirps. So that's interesting. And then below the giant picture, it says a formula that is commonly used to find the temperature in degrees Fahrenheit. Oh, I think there's a typo. I don't see the. Oh, okay, sorry. So it's just written out in words. Count the number of chirps in 14 seconds and then add 40 to get the temperature. So we count up the chirps and we add 40. So what is the temperature when the cricket chirps 52 times in 14 seconds? So all we have to do is count up the number of chirps, it's 52, and then add 40, so add 40. So if the number of chirps is 52, then the temperature is 92 degrees. Nice and warm. All right, for part B, write an equation that defines f as a function of n, and n is the number of chirps that the cricket makes in 14 seconds. And f is the temperature in Fahrenheit. All right, so when we did this one here, this 52 was the number of chirps, so that was n, and our answer was the temperature in Fahrenheit, so that's F. So then our equation is simply going to be F equals N plus 40. Okay, part C, how many chirps would we expect to hear in 14 seconds when it is 60 degrees Fahrenheit? This 60 degrees Fahrenheit, that is F, that is the temperature. Okay, so this I'm going to put in the place of F. So 60 equals N plus 40. And to solve that, we simply subtract the 40. And so N equals 20. And that means if it's 60 degrees outside, we would expect to hear 20 chirps in a time span of 14 seconds. So the final answer is 20 chirps. All right, and then the last question on part D is to write an equation that defines N as a function of F. Okay, so we're just going to say, oh, well, we are going to look at this equation. And so if we wanted to get N by itself, we would simply subtract the 40 from each side. And so for D, I can say, well, those 40s cancel out. So N equals F minus 40. All right, that is the end of your assignment. I hope you found the video helpful.